Good morning, everybody. So today we're going to talk about perimeters and areas of similar figures. Now, this is one of the tougher lessons that we have in this unit. When two figures are similar, the ratio of their perimeters are equal to the ratio of their corresponding sides. So, first thing I guess is we look at, are these two figures similar, and if so, why, and if not, why not? Okay, so the first thing we always check is, are all the corresponding angles, are they equal? So this angle's 90, this angle's 90, this one's 37 and 37, 53 and 53. That checks the first box. So the angles are equal. Now, the next thing is, are the sides proportional? Okay, this is where most people make their mistakes. So 6 over 3, we compare 6 over 3 to 8 over 4. To 10 over 5. Are all those things equal? And they all reduce to 2 over 1. So yes, the sides are proportional. This implies the sides are proportional. By the way, this little arrow, double arrow like this, means implies in math. You should know that. That's something that's going to come up more and more. Okay, and all corresponding, we're going to abbreviate that, CORR, angles, there's a little angle sign, are equal, and that implies they are similar. Okay, so they're similar triangles. Now, find the perimeters. Okay, so perimeter is easy to find. Perimeter of this one is going to be 3 plus 4 plus 5, which is 12. And the perimeter of this one over here is going to be 6 plus 8 plus 10, okay, which is 1824. Okay. So, compare the perimeters, what do you notice? So if we compare, that usually means, divide these things. So if I take the 24 and I divide it by 12, I get 2 over 1, which is exactly the same as the ratio of the sides. Which it makes sense. If all these sides are twice as big as this side, then the perimeter of this thing is going to be twice as big as the perimeter of this one. Okay, now it doesn't have to be twice as big, it can be any ratio, but we get a theorem out of this, and it says if two figures are similar, the ratio of their perimeters is the same as the ratio of their sides. Okay, so that's a good one to know right there. Usually not too much trouble with the perimeter part. So example, find the ratio, red to blue, of the perimeters of the similar rectangles. Well, okay, they tell you it's rectangles, so that tells you right away if it's a rectangle, all these angles are 90 degrees on all of them. So I know the angles are equal, and they're telling you that these are similar, so the sides are proportional, and the ratio of the sides would be 4 to 6. Whoops, don't like that. 4 to 6, which is basically 2/3. Okay. And so the perimeter, the red one is going to be 2/3 the perimeter of the blue one. So there's the ratio of the perimeters. And it says red to blue, so red goes on top and blue goes on the bottom. If it said blue to red, we would flip this over and be 3 to 2. Okay, so let's look at a triangle. Now we got to refresh our memory here. The area of a triangle is half the base times the height. So remember, here's my base, and the height is always perpendicular to the base, and it goes to the vertex. So if we find the area of this rectangle right here, and always write your formula down every single time. Okay. I can't tell you how much that makes it more accurate for you when you do these problems, because remember, the formula tells you where everything goes. That's what it's for. Okay, if you know the formula, it tells you, oh, the base goes here. I know the base. The base is 18, so it goes right there. Oh, the height goes here. I know the height. It goes right there, so I must be figuring out the area because that's the one thing that I don't know here. Okay, and half of 18 is 9, and 9 times 4 is 36, so this is 36. This is in centimeters, so this would be 36 square centimeters. Okay, here's the area of my triangle. Now, some people want to get lazy with the formulas because, oh, I know that one, it's easy, but not all the formulas are easy. And depending on which variable you're solving for, it's a lot easier to just write the formula down and fill in the numbers where they go. Okay, so here we're going to find the ratio of the areas of two similar figures. So they're telling you these are similar. All right, first question is, what is the ratio of the two figures? So I've got, it doesn't matter which direction I do it, but it's 14 to 7, which is 2 over 1. Now, if you put 1 over 2, that's fine. Okay. What is the ratio of the perimeters? Well, here, the perimeter would be 14 plus 5 is 19, and if I double that for the other side, that's going to be 38. And over here, it's 9.5, and if I double that, that's going to be 19. Okay, so the ratio is 38 to 19, which is 2 over 1 again. So the perimeters are the same. What's the ratio of the areas? All right, let's look at the areas now. So the area of this one is going to be, remember, area of a rectangle is base times height, right? So this is going to be 14 times 5, which is going to be 70 square centimeters. Whoops, that's not my answer, so let's not put a box around that. Okay, now I got to figure out the area of the other one. So the area of the other one is going to be 7 times 2.5. Okay, so that would be the same as 7 times 25, which would be 175. But I move the decimal over, that's going to be 17.5 square centimeters. Okay. Now, what's the ratio? The ratio is going to be 70 divided by 17.5, which comes out to be 4 to 1. There's the ratio of my areas. Now, the big question is, do you see a relationship between them? Well, a lot of people don't see this relationship. But here's the thing. Let's say that I took this rectangle here, and I divided it in half this way. So this would be 2.5, and this would be 2.5. And then I divided it in half this way. This would be 7, and this would be 7. And so if you look here, hey, that's the same. Each one of these small rectangles is the same as this one over here. So the area of this rectangle here is the same as that rectangle here, but it's the same as all these other ones. So you can see it's a ratio of 4 to 1. Now, why is it 4 to 1 and not 2 to 1 like the perimeters? Well, the thing is not only did I double it this way, okay, it's twice as big this way, but it's also twice as big this way. So 2 times 2 is 4, all right? So the relationship is 4 to 1, and you can get that from this, okay, or from this. That's just 2 over 1 squared. Okay, so whatever the ratio between the two figures is, the ratio of the areas will be that squared. So if this was 3 times bigger than this, the area would be 9 times bigger than this. If this was 4 times bigger than this one, the area would be 16 times bigger than this. Okay? All right. So the two triangles are similar. Find the area of the smaller triangle. Okay, now here's the problem. I don't know the heights. Okay, but I do know the area of this one. The area of this one's 72 square centimeters. And I know two sides that go together. So I know that this one is 6/9 or 2/3 the size of that one. So there's my my scale factor is 2/3, which means the area is going to be, the area of this one is going to be 2/3 squared times this. So if I take 2/3 and I square it, remember that's 2/3 times 2/3, which is 4/9. So the area of this one's going to be 4/9, whatever that one is. So I can just take 72 over 1 times 4/9. Oh, let's see, I can cancel that with this, make that 8, and 8 times 4 is going to be 32 square centimeters. So there's my area of this triangle here, and I didn't have enough information to figure it out on its own, but I could figure it out from this one. Okay, a swimming pool is similar in shape to a volleyball court. Find the perimeter P and the area A of the pool. Okay, so here's what we have is we have two sides that correspond, 10 and 18. So 10 over 18 reduces to 5/9. So the volleyball court is 5/9 the size of the pool. Oh, always check the units too, because that can be tricky. If one of these was given in feet and one was given in yards, that would change your answer a lot. Okay, so fortunately they're both in yards. Now, the perimeter of the volleyball court is 60. Okay, so here's the thing. 5/9 is the scale factor. This is the smaller one. So over here, I'm going to put the perimeter of the smaller one here, and then I'm going to figure out the perimeter of the pool. Okay, so let's see. I can kind of 3 will go in here 20 times, and 3 will go in here 3 times. So 3 times x is going to be 3 times 20 divided by 5. Okay, and I can cancel that with that, and that's going to be 12. And that's wrong. What happened? So the perimeter is 60 yards. The perimeter, that can't be right. That's not right. So somewhere I made a mistake. Oh, you know what? I should not have done this. I should not have canceled these here. Let's try this again. This would be 60 times 9 would be 9 times 60 divided by 5. That'd be 540 divided by 5, which would be 108. Okay, so this is going to be 108 yards for the perimeter. Yeah, you don't want to cancel that on this problem before you do that. Okay, so there's the perimeter of the pool, is 108 yards. Now the area, okay, so the area is going to be related to the square of this. So I'm going to take 5/9 and square it. That's going to be 25/81. Okay, and then I've got the area of the smaller one is 200, and the area of the larger one, the pool, we don't know yet, so we're going to figure that out. Again, don't simplify this yet. Okay, so y is going to equal 81 times 200 divided by 25. Okay, so, wow, let's see, 200 times 81. 81 times 2 is going to be 162, add two zeros, so this is going to be 16,200 divided by 25. Okay, so let's go ahead and divide that by 25. That'll go in here for 6 times, that's 150. That leaves 12, drop a 0. That'll go in there 4 times, that's 100. 20, drop a 0, that'll go in there, 8 times. So, this comes out to be 648 square yards. Okay, so there you go. Make sure you get your units right, perimeters in yards, areas in square yards. Make sure you put the fraction together right, so obviously the area of this one should be bigger than the area of this one. I can't tell you how many times, the area of the pool should be bigger than the area of the volleyball court. Like I was going to say, I can't tell you how many times somebody gets this flipped upside down, and so they end up with the right ratio, but they've got the pool, even though it's bigger, being that ratio smaller than the volleyball court. Okay. So, 1 through 23 odd is what we will do for an assignment in class. I hope this helps, and I will see you next time.